on July 10th of this summer, NASA's Sophia Observatory will help out another NASA mission, NASA's New Horizons.
Welcome to the mission brief for Flight 417. This is the MU-69 occultation flight.
So for the last 2 days, we met up with the mission planners and the pilots.
Weather, as you saw this morning, we had plenty of fog out here. That has lifted and is forecast to come back tonight.
The SWRI scientists were still updating the predicted latitude and longitude and time of where we needed to place the plane.
We're flying past MU-69 on New Year's Eve and New Year's Day of 2019 at a speed of almost 35,000 miles an hour. So any debris impact whatsoever could be fatal to the spacecraft. And what we're doing here with Sophia is putting a very large telescope into the occultation path so that we can probe very close to the target.
An occultation measurement is when an object passes in front of a background star, and we observe a dip in the light as the object passes in front of that star.
The reality is there's so many details. What are the winds doing, and where are the flight paths for the airplane, what altitude you're going to go. We had to worry about a turbulence zone that we might have to fly around. And the last second they ended up picking up a headwind that was slowing the airplane down, and the pilots had to adjust and adapt constantly.
Well, the occultation that we're going after is super challenging, primarily because MU-69 is a small body, and its shadow falls over a very small area here on the Earth. And we have to have the airplane under that shadow, which is moving at about 100,000 kilometers per hour at just the time the shadow is there.
And I show a spot on. 2 minutes to go. 30 seconds to go, we're looking good. Planes are spot on.
Ready. Mark. Nailed it.
You got it, spot on.
Yeah.
Yeah,
okay.
Excellent job, everybody.
Success tonight is putting Sophia in the right place at the right time to have that big glass, the 2-meter telescope, observing the occultation star as it passes close to MU-69 and giving us a trace all the way across the space near it for debris. If we can get that, Sophia will have done its job and done something no other observatory could do for this occultation. And it'll be a real credit, I think, to the entire Sophia program.
From an operational standpoint, getting to an occultation point on a 10-hour mission within a second of when the scientists wanted us to be there and exactly on the latitude and longitude was a challenge for us tonight, but we pulled it off, and it was a really wonderful piece of crew coordination between the mission director, the navigator, and us flying the airplane. But from what I understand, we nailed it on the head and within 1 second and exactly where we needed to be. So I think the scientists are quite happy.
Really, the point of these occultations is the hazard search. It's to make sure we can go close to the object. And the fact that we have not seen any obvious rings so far in any of these occultations says that we can go close to the object and have a really close, exciting flyby.
Our quick look data reduction software did not reveal the occultation dip in the light curve immediately to our eye, but it is very difficult, and we anticipated it would be very hard to see it with our eyes immediately, because all you have to do is blink and you've missed it. But all the data was taken, and now the data is being analyzed.